Hello students, so today we are going to start our next chapter, states of matter. In the given chapter, we will deal mainly with the one of the state of matter, that is gas state. Apart from that, we will take some basic introduction of some property of liquids and solids. Slight introduction can be discussed in basic properties only, because the chapter solid state is given separately in class 12th chapter under heading solid state. So in that chapter solid state, we will study about different kind of properties of solids, packing of particles in solid state, different kind of ionic crystal structures in solid state, defects, all that points we will discuss in chapter solid state in class 12. But in this chapter states of matter 11th class, this chapter majority part is dealing with the gaseous state. So sometimes this chapter normally is studied under also heading gaseous state. So by the way, in the given chapter what we will discuss about first introduction of three types of matter, and then mainly we will discuss about different gaseous state topic. Especially in topic gaseous state we study about different gas laws. Basically, gas law gives the variation of pressure, volume, temperature and number of moles if one is kept constant, other variable. Or we can take two property constant, how on changing one property, second property will change. In the gas law we study about here Boyle's law, Charles law, Gay-Lussac's law, Avogadro's law, then you can take Dalton's law of partial pressure, Graham's law of diffusion or effusion for the gases. They are basic laws, and then using the different law you can take combined gas law or ideal gas equation using this four, or in fact three only: Boyle's law, Charles law, Avogadro's law. We can get expression called ideal gas expression equation, Dalton's law, Graham's law. In entrance we may get question from any of the laws or laws combinations as well. And after that, in the topic gas state, when we read the different gas law, we can take introduction of kinetic theory of gases, and then we can take different types of molecular speeds of the gas molecules. Like we will take root mean square speed, then you can take average speed, and then you can take most probable speed of the gas molecules, and then you can take Maxwell's distribution of the molecular speeds graphically, and then we take van der Waals gas equation. We take next van der Waals gas equation for real gases, van der Waals gas equation. We apply for real gas or real gases, van der Waals gas equation, and different variations of van der Waals equation, because in exam van der Waals equation based questions are given most frequently in different kind of entrance examinations. So you have to read this expression especially carefully, different conditions, how the equation modify, that point is again very important. And then you can take several more topics like liquefaction of gases, critical constants, then you can take here critical constants. We take like critical pressure, critical volume, critical temperature, their significance. And then about liquid states, some property of liquids we can discuss. Like we take property of liquids: vapor pressure, surface tension, viscosity, boiling points, etc. So there are different properties of liquids about which we will discuss In brief, basic variation, how they can change on changing pressure or temperature, these properties of liquids. So that is the chapter outline of topics or subtopics that we are going to cover in the given chapter. In different gas laws, you can get graph based questions, again which are quite important in different entrance examinations. So anyway, we will cover all these topics in the given sequence as it is given here. This chapter is very important because this chapter is linked to your many chapters in chemistry. Like when we study thermodynamics, we will use the different gas law, ideal gas equation at many points, because there we take pressure, volume, work for the gases to be done. In that case, we are using gas law, especially this Charles law, Boyle's law. Boyle's law especially is used commonly. And then you can take here this concept are used in chapter of kinetics. Gas law we can use in mole concept, or in fact in any chapter they can be used. Different gas laws, even electrochemistry sometimes we are using in gas electrode based questions. Pressure variations are helpful or required to us. So means almost can take any chapter. In fact kinetics also, kinetics, or can take your electrochemistry, thermodynamics, or mole concept, stoichiometry, in which this chapter can be finding applications. Okay, so it is one of the basic chapter of chemistry which the student should be very clear for doing questions in different kind of entrance examinations, as well as for understanding of the chapter coming ahead, like thermodynamics, especially thermodynamics, or you can take kinetics. These two topics are finding more use, but otherwise indirectly or directly some gas flow based questions can be given to you almost in entire chemistry in this topic. Okay, now coming first from this introduction of matter. Now matter can be taken in three states. We take in general: solids, liquids and gases. Sometime we take two more states have been recovered. We can take one is called as plasma state, in which we can take let us discuss coming on this point. Now classification of matters, we can have matters in three common states, which is called as solid state, liquid state and gaseous state. This refer to what? They refer to the condition of room temperature. At the condition of room temperature, a substance can be found in solid state or liquid state or gas state. Moreover, remember, the same substance can exist in solid state or liquid state or gaseous state at different temperatures. If you take common example is water. When it is water taken at temperature below 0 degrees Celsius or even 0 degrees Celsius, it goes to solid state, ice formation. When you take temperature more than 0 degrees Celsius, it is liquid state called water. When temperature exceeds 100 degrees Celsius, it convert to vapor phase, gas phase. So we can take this states will depend on temperature. Sometimes same substance can be found in all three state of matter as well simultaneously. Like we can take water can exist in solid state, liquid state and also gaseous state when we have temperature 0 degrees Celsius and pressure 4.58 millimeter of mercury. That temperature is called as triple point. Means we can take water can exist in all three states. That indicate pressure of 4.58 millimeter of mercury and temperature 0 degrees Celsius. At this temperature, it is called triple point of water. Water can exist in all three states of matter simultaneously: solid state, liquid state and also gaseous state. Now before we go for their more properties, differences, we can take we have two more states of matter which are found recently. Like one is called plasma state. Plasma state basically is consisting of superheated gaseous state consisting of mixture of electrons and positively charged ions with unusual properties. We have just discussed it, remember, in topic atomic structure. On passing high voltage, strong electric field through the gas. At low pressure, the gas undergo ionization. They produce electrons and positive ions remaining. So that basically can be taken plasma state. This plasma state is found at very high temperatures. We can take this temperature requirement can be fulfilled in the interior of the sun or stars. In intense electric field like discharge tube already explained to you. So this very high temperature can be found in the interior of the sun or the stars. The scientists have revealed that we can take 99% of the entire matter of universe is in plasma state, consisting of electrons and the gas state. That is fourth state we can call. आपको इसके बारे में बहुत नहीं पढ़ना है यहाँ पर चैप्टर में. हमारे चैप्टर में पढ़ना है मेनली यहाँ पे चैप्टर में about the only topic gaseous state. Anyway, one more state is taken called supercooled solid state, in which atoms lose their own identity, get condensed and behave like single superatom. आप सारा नोट कर लीजिए पॉइंट्स को. Single superatom. It is based on the Bose-Einstein's condensation (BEC) concept, which was developed in the year 1924. In the year 1924, in that year, this concept was developed. Bose-Einstein's condensation concept. So anyway, this can be taken the states of matter introduction. Now we will discuss some properties and difference in the properties of these three states of matter: solid state, liquid state, and the gas state. It depends simply energy. A given substance can exist in what state? Physical state, solid or liquid or gas. It depends upon the temperature or the energy, thermal energy, and the attractive forces. They decides कि the substance can exist in what physical state. Because same substance can be occurring in three states at same temperature or at different temperatures. So let us take some differences of the solid state, liquid state, and the gas state. Now coming on differences in the three states of matter, which have been summarized here in the given table. The key differences have been given in the table. First we can take column solid state, second liquid state, third is gas state or gases. So solids, liquids and gases, what their key differences is given here. आप लोग सारा टेबल को नोट कर लीजिए पॉइंट्स को है. मैं सारे पॉइंट आपको बगैर बोल दे रहा हूँ. आपको पता है you can experience these properties. बहुत सिंपल है. पहले क्या होता है in the solid state or solids, the molecules are closely packed. They are not able to move from their positions. They are held in fixed, tightly in same positions. यहाँ पे क्या होता है molecules are held or can take are held loosely or they are less closely packed. Example, see water. Molecules can move in the given state. Whereas in gases, molecules are far apart from each other. If you can see the gas in atmosphere, we have nitrogen gas, oxygen gas, CO2 or other polluting gases also. So they have what? Far apart from each other in solids in the gas state. Next can be taken attractive forces. For a substance to remain in solid state or to occur in solid state, they should have strongest attractive forces among the particles, which can be atoms, ions or molecules. तो क्या लिखा है? They have strongest attraction forces in the particles. In this liquid state, we have weaker attractive forces among the molecules. While we take in gaseous state or gaseous molecules, they are having negligible attractive forces. Because of strong attraction force only, they can remain closely together in solids and then they can move. But in gas phase, what happen? They can move freely because of negligible interaction forces in the molecules. Next point taken, density. It depend on packing. Due to close packing, they have higher density. In liquids, density is lower compared to solids, but more compared to gases. Property will be intermediate. इससे difference होगा इसमें. तो in this case, density is lower than solids, but more compared to that of gases. अगला point क्या है? Position of molecules are fixed. Why? Because of strong attractive forces. In solid state, the position of molecules or particles are fixed. They are unable to move from their positions, and they have no translatory or rotatory motion, or no translational or rotational motion of the particles or molecules, but they only have vibratory motions. कि particles can only vibrate at their own positions, they cannot travel, rotation is not allowed because of strong interaction forces. While we take in liquid states, they have greater freedom of movement of particles, they will possess some translatory and rotational motions in addition to vibrational motion. While we take in gas phase, molecules have large translatory, rotatory and vibratory motion. Molecules can move from their 1 to 2nd positions, translational, rotation on their own axis, they can rotate in any directions, or vibrations, vibrating in their own positions. Now, energy of particles, for the substance to remain in solid state, they should have lowest energy. With their lowest energy, then they can remain in solid state. Energy is higher compared to liquids, higher compared to solids, but lower compared to gases. And in the gas phase, molecules are most energetic. Molecules have high energy, molecules are most energetic. Then we can take solids, they have definite shape and volume. Definite shape and volume, if I take this marker, cylindrical, it have definite shape and volume also we can calculate. So we can have solids, they are having definite shape and volume both. But when you take in liquids, they have definite volume but not definite shape. If you take water, we can put in glass, जो shape glass का है उसका shape हो जाएगा इसमें. We can put water in jug or other container or different containers, तो they have definite volume. Volume समय same रहेगा, सारे केस में volume same रहेगा, but समय क्या होगा इसका shape change हो जाएगा. और इसमें क्या होता है गैस में, no definite shape, no definite volume, no definite shape, no definite volume. Volume is variable. Change in pressure, temperature, the gas can change volume to large extent. यहाँ पे क्या होता है next last point आपका आएगा difference में, they have least thermal expansion and compressibility. Suppose on heating, volume change in solids is negligible, least thermal expansion, or on applying pressure, the change in volume also negligible. Change in volume also negligible. In liquid state, they have slightly more thermal expansion or compressibility factor, or compressibility more, slightly more. Means both the properties taken here are slightly more in liquids, while in gases they are highly compressible. Volume can be decreased to very low volumes, applying very high pressure values, or they will have very high thermal expansion. On heating, the volume can increase to again large extent. But in this case, volume change is negligible on changing temperature. Also pressure changing, applying pressure, volume change is negligible. So can take less compressibility in this case compared to gases, and also less thermal expansion. यहाँ पे least होता है, यहाँ पे less, यहाँ पे highest. That is what we can see the differences in the properties of solids, liquids and gases. In the chapter mainly we will discuss with the gaseous state. So we will take about gaseous state, properties variation, we will discuss under different gas laws. But before that we take properties of gases. Okay, gas will have pressure, then unit of pressure, volume, unit of volume, temperature, relation of temperature in different scales. About that we will discuss in the introduction part of our gases part. Okay. Now in continuation we have discussed the difference of solids, liquids and gases. The property of liquids are intermediate between that of solids and gases. Depending upon the energy, or you can take attractive forces, we have taken differences, and they affect the other properties of the solids or liquids or gases as well. We have taken one term, thermal energy. What is thermal energy? Thermal energy can be taken the energy of the body arising from the motion of its atoms or molecules. What is thermal energy definition? आप देखिए इसको definition को. It is the energy of body arising from the motion of its atoms or molecules. It is directly proportional to temperature. And then further we can take, it is measure of average kinetic energy of particles of the matter. It is measure of average kinetic energy of the particles of the matter. And further, it is responsible for the movement of the particles. How your particles can move, we have discussed. We can have translatory motion, vibrational motion, rotational motion. In gas, they have highest freedom for movement, in liquids less, and solids least. In solid already discussed. In solid state we have no translatory motion, no rotational motion, we only have vibrational motion. On the on positions, particles can move in solids, whereas when you take liquids or gases, they have comparatively higher movements. So basically this kind of motion of particles which arise from the due to thermal energy is called as thermal motion. Now if I take solids, liquids or gases, we can categorize. We already discussed here that when you take the measure of intermolecular forces can be taken of different categories. We have discussed in chemical bonding, we can have strong or weak forces. When you take a weak force, like we can have van der Waals attractive forces, which were taken as dipole-dipole interaction, dipole-induced dipole interaction, or other London forces. Whereas other force can be like hydrogen bonding in between different molecules, or you can have ion dipole interactions. We have discussed so many kind of interactions earlier in chapter chemical bonding, so you can recall them from the bonding chapter once again. So when you take this point here, gas to liquid to solid, what happened? The intermolecular forces, they are increasing. Solids are having strongest intermolecular forces and gas will have least. In fact, gas will have negligible forces of interactions. While you take thermal energy, इसका order उल्टा होता है. Solids will have lowest thermal energy, then liquids, and then gas. When you take thermal energy, for solid is lowest, because simply आपका force higher होंगे तो they can have less mobility, less movement possibilities. So इसका order उल्टा आता है. The energy, thermal energy order and the order of the intermolecular forces. Now we will discuss in topic further now about gases. So already we have taken gas some properties, like we have already taken some property of gases, like we can take gases are having weakest intermolecular force of attractions. They can move freely in the space. They are highly compressible. They can be compressed to very small volume on changing pressure, and they also can expand to large volume on lowering of pressure. So the gases can show different kind of these variations in the properties. Now we can have property of the gas, mainly four properties: pressure, volume, temperature. They are normally variable, and one is amount of gas, number of moles, that is fixed. So it can change if you want to change. Otherwise we see variation of these properties: pressure, volume, temperature and number of moles by some laws which are called as gas laws. Before you take gas law, some points more you can take here. Okay. If you take in the periodic table, we have only 11 elements are gases. If it is taken in periodic table, only 11 elements will be gas at room temperature and in atmospheric conditions of pressure. कौन से आपके एलिमेंट होते हैं? आपका एक है हाइड्रोजन, then we can have nitrogen, oxygen, fluorine and chlorine. 4 plus 1 5, and all noble gases: helium, neon, argon, krypton, xenon, radon. So 6 plus 4 plus 1, these 11 elements will be existing as gas in the entire periodic table. So about them, when they are existing as gases, we study the variation of properties like pressure, volume, temperature and number of moles. We study their variations on changing one property, how second property will change, keeping some other properties constant. That all the relations are called as gas laws. Now before we take gas laws, because we take gas law can be applied for only ideal gases. अब इसका मीनिंग क्या होता है? The gases can be taken two types. One are called real gases, one are called ideal gases. So let us take an introduction first, and then we take the gases and the gas laws. Gases can be taken two types. One is called as ideal gas, and second taken real gas. Gas can be ideal gas or real gas. What are ideal gases? Because we are studying different gas laws for ideal gases or ideal gas. देखिए ideal gas कुछ होता नहीं है. There is no gas which can be called perfectly ideal gas. The gas can show ideal behavior. Ideal gas can be taken as a hypothetical gas, assumed gas, or the real gas can behave as ideal gas in some set of conditions. So in ideal gas, what are the key properties? Right now we will focus on two properties. About the many properties we can study in topic kinetic theory of gases. For the ideal gas, we can take properties like for them the properties can be taken. First of all, they have no interaction forces. No interaction forces among the gas molecules. Among the gas molecules. They have no attraction, no repulsion among the gas molecules, which is practically difficult when placed together two molecules. When placed together two molecules, they can have some kind of interaction forces. Already discussed, even the non-polar molecules, like we take noble gases, they also can develop in them some interaction forces, which are called as London forces. So in the molecules of gas, they can have some interaction forces, but in some set of conditions, when we can say practically there is no interaction forces. We say practically when there are no interaction forces, no attractive forces among the gas molecules, then we can use this point. Then in that condition the gas can behave as ideal gas. It is one condition. One more condition we have is that the volume of the gas molecules is negligible. Volume of the gas molecules is negligible as compared to volume of the gas or the container. Already we have told you that gases do not have their own volume, or the volume is not fixed of the gas. The volume of the gas is same as the volume of the container or the vessel in which they are present. The volume of the gas is same as the volume of the gas or the container in which they are present. So in these two conditions, when these two conditions can be obeyed by any gas, we can say the gas will behave like ideal gas. So it is one conditional hypothetical gas, assumed gas here, ideal gas. Set of the gas molecules can behave ideally in some set of conditions, and the other gases which do not fit or do not obey these two conditions will be called real gases. They are actual or real existing gases. In fact, truly speaking, there is no gas which can be called perfectly ideal gas. There is no gas which can be called perfectly ideal gas. These points we will discuss in more detail when we take topic kinetic theory of gases. Moreover, these points also are required or are the basis of derivation one expression called van der Waals equation for real gases. The van der Waals equation is based on these two faulty assumptions. There are two assumptions. When we study here, there are two of the assumptions of the kinetic theory of gases. We can have more assumptions like collision of molecules are elastic in nature, perfectly elastic in nature if it is ideal gas. Collision of molecules are elastic nature means their kinetic energy or momentum remain unchanged before collision and after collision. Next can be taken like here, properties that the gas can exert pressure due to collision of the gas molecules with the walls of container. That is, gas will exert pressure due to collision of the gas molecules on the walls of the vessel or the walls of container. And then we can take here for the gas, the average kinetic energy of gases is function of temperature. There are 5 main postulates in brief I told you, but right now we are focusing on the gas only right now, ideal gas, because हमारा next topic है gas laws. वहाँ पर हमें सारे gas law पढ़ने हैं और सारे gas law किसके लिए valid होते हैं? Only for ideal gas. तो ideal gas for time being you can assume that they are characterized by these two conditions or properties. Okay, among the gas molecules, there are no interactive forces, no attraction, no repulsion forces, and the volume of the gas molecules is negligible as compared to the volume of the gas or the container. In these two set of conditions, the real gas can also behave as ideal gas. And then the ideal gas is characterized by equation called PV is equal to nRT. It is equation for the ideal gas. It is called ideal gas equation. It's called ideal gas equation. In the given gas, P is pressure of the gas, V is the volume of the gas or the container, N is number of moles, T temperature, and R is called as universal gas constant. Universal gas constant. R is universal gas constant is equation called ideal gas equation. It is derived by those combined gas laws. But actually in some other different gas law, we will have some graph based questions. For the graph based question, this equation will be helpful to you. Already this equation was given to you in some chapter, in the chapter some basic concepts of chemistry using the basic laws. So this gas equation will be used for driving or for depicting the graphs nature कि ग्राफ में कौन सा ग्राफ किसके लिए आता है, और ऐसे क्वेश्चन कॉमन आते हैं एग्जाम के अंदर और बच्चों को भी इसमें प्रॉब्लम होता है ग्राफ के लिए. तो फॉर द ग्राफ अंडरस्टैंडिंग दिस इक्वेशन आई एम जस्ट गिविंग राइट नाउ आफ्टर द लॉस कंप्लीशन ऑफ Boyle's law, Charles law and Avogadro's law, this equation can again derive. Okay. Now before we take the equation, we can take the units of different terms in calculations. What units should be taken for pressure or volume or temperature or R value. First we have taken the equation PV is equal to nRT. The equation called what here? It is called ideal gas equation. Meaning the ideal gases can obey this equation, in which we can relate the property of pressure of the gas. So we can take first pressure. Pressure can be taken different units. In fact, it can have many units. But among the many units, we will take only few units of the pressure. क्या क्या आपको यूनिट होंगे प्रेशर के लिए यहाँ पर देखिए. First we can take pressure. Unit can be taken Newton per meter square or pascals. You can take 1 Newton per meter square is equal to 1 Pascal. It is taken when you take force in Newton and we take area as meter square or SI units. In SI system, it's the unit of pressure. 1 Pascal is same as 1 Newton per meter square. Then you can take other unit taken here, 1 atmosphere. Very common unit in question taken. 1 atmosphere is how much? It can be taken relation with this pascals 101,325 pascals or Newton per meter square, or can write here 1.01325 into 10 to the power 5 pascals. In short we write pascals as PA. Then you can take 1 atmosphere is also in right. This is written in short here 1 atm. 1 atm can be taken also equal to 760 millimeter of mercury when pressure given in scale of millimeter of mercury, or 760 torr or 76 centimeter of mercury. Then we take one more unit, 1 bar. 1 bar is equal to 1 and 10 to the power 5 pascals. So if we take relation of these two values, is quite similar. We can write here this value is how much here? 1 bar. So I can write here 1 atmosphere is equal to 1.0325 1.01325 bar, or 1 bar can be taken 0.987 atmosphere. For pressure you can take several units more, like dynes per centimeter square, not used in our questions of JEE syllabus, or we can take other exams also. So we can take this common units that you have to keep in mind. One, it is taken short. 1 atmosphere is written as ATM also. Relation क्या है? 1 Newton per meter square is equal to 1 Pascal. 1 atmosphere is equal to 101,325 pascals or 1.01325 into 10 to the 5 pascals or 760 millimeter mercury torr centimeter. That is the relation of pressure in different units. I hope it is clear. Now next we take unit of volume. Volume can be taken again different units. For the gases, 1 cubic meter is taken 1000 liters or 1000 decimeter cube. 1 liter is taken 1 decimeter cube or 1000 cc or milliliter. There are different relations of the volume. 1 liter, or you can take 1 decimeter cube is 1000 cc. Then you can take temperature. Temperature, we have different scales. I'll take next. Now we can have temperature in different scales. Again, we can take temperature in scales like taken here, degree Celsius. Temperature in degree Celsius. We can have temperature in Kelvin scale or temperature in Fahrenheit scale. We have 3 scales. One take degree Celsius, temperature in Kelvin scale, and it is taken degree Fahrenheit. तीनों में रिलेशन क्या होता है? If I take temperature in degree Celsius, minus 0 by 100 minus 0 is equal to temperature in Kelvin scale minus 273 by 373 minus 273, or it can be taken temperature in Fahrenheit scale minus 32 by 212 minus 32. That is how we can relate here. In solving our questions, we get temperature mostly in Kelvin scale or Celsius sometime, or we have to take temperature always in Kelvin scale. In this applied equation, we will take temperature to be taken in Kelvin scale. यहाँ पे वो temperature in Kelvin scale. So when we relate here, this can be taken temperature in degree Celsius by 100 is equal to temperature in Kelvin scale minus 273 by 100, or it is temperature in Fahrenheit scale minus 32 by 180. So this can give relation for our all the scales here of temperature. Most commonly are used these two scales. So you can take temperature in degree Celsius will be how much? Temperature in Kelvin scale minus 273, or we can write here temperature in Kelvin scale is equal to temperature in degree Celsius plus 273. That is relation of temperature in Kelvin and Celsius. So in solving or applying this relation, we will take temperature in Kelvin scale. If we are given Celsius or Kelvin or Fahrenheit, we can have relation of the temperature in 3 scales this way. This is the common can use equations. So as per relation, we can use the equations here. Then coming on the gas constant, n the number of moles, n is number of moles of the gas. How to find the number of moles of the gas? It is taken weight if the weight given by the molar weight of the gas can give the number of moles. Now coming on the R value, R can have different units. For R, we can have one unit taken as 0.0821 liter atmosphere per mole per Kelvin. A big unit. 0.0821 liter atmosphere per mole per Kelvin. So it is very evident that here this value of R we will use when we take pressure in atmosphere, volume in liters, temperature in Kelvin scale. Then we take this value of R. For R we can have other units as well, like it can have value 8.314 joules per mole per Kelvin. This value of R, it is taken for R, the value of R in SI system. This value of R we use when we take pressure in Newton per meter square or pascals, volume in cubic meter of the gas, T temperature in Kelvin scale. If we take pressure, volume, temperature in the given scale, then we take this value of R. For calculation of energy in joules or for calculation of gaseous speed of molecules in meter per second, this value of R we will use, and definitely take T in temperature in Kelvin scale in all expressions. For R we can take other units. It was 1.97. For doing question take 2 calorie per degree per mole. We can have other units, 2 calorie per degree per mole. The value of R, if it is taken energy calculations in calories, so we can have these two value of R. You should remember or keep in mind. In this expression we can take sometime pressure is taken, suppose bar. We have some modification. We have taken already that 1 bar and 1 atmosphere are nearly same but not same exactly. So one for R we can take one more value, 0.083 liter bar per mole per Kelvin. The value of R can be taken 0.083 liter bar per mole per Kelvin. This value of R is used when we take pressure in pascals, pressure in bar units, pressure in bar, volume in liters, temperature in Kelvin scale. मोल तो सब में कॉमन रहेगा. तो this value of R we can use 0.083 liter bar per mole per Kelvin if we take pressure in bar, volume in liters and temperature in Kelvin scale. Then the value of R we can use is 0.083. तो आप क्वेश्चन देख लेंगे कि क्वेश्चन में क्या यूनिट है प्रेशर का. हमारी देखिए रिक्वायरमेंट क्या है सारे केसेस में. यहाँ पर इस इक्वेशन को सॉल्व करने के लिए कॉमनली जो लगते हैं या मोस्ट कॉमन करते हैं क्वेश्चंस में, वहां पे प्रेशर होगा आपका, किसमें लीड प्रेशर का होगा, एटमॉस्फेयर में होता है और समटाइम बार. आपको नहीं तो ये लेना पड़ेगा इसमें. वी विल टेक प्रेशर इन एटमॉस्फेयर और बार टू अप्लाई दिस इक्वेशन. देन वी टेक volume in liters, then we take value of R 0.0821 or 0.083 as per the pressure unit, atmosphere or bar, then this unit, and then temperature in Kelvin scale. बाकी n तो number of moles है, n is number of moles. To apply the ideal gas equation for any questions, we will take these terms or different terms like pressure in atmosphere or bar units, volumes in liters, R 0.0821 temperature in Kelvin scale, n is number of moles of the gas. So different units or value you can take here of R. Be careful in attempting questions on this ideal gas equation based questions. We will come again back on calculation based questions on this topic, but since for study of gas laws, graph study especially, we require this equation. ठीक है? So there are different units. I hope it is clear. Units में बहुत ध्यान रखिए. अगर बच्चे गलती काफी करते हैं, बच्चों का सिली मिस्टेक हो जाता है. क्यों होता है सिली मिस्टेक? वैल्यू ऑफ R में बहुत कॉमन मिस्टेक बच्चे करते हैं. R का वैल्यू आपको लेना है, जैसे क्वेश्चन है उसको देखिए ध्यान से कि डेटा किसमें दिया है इनको. अगर हमें गैस के मोल्स निकालने होते हैं तो हमारा इक्वेशन फाइन, ये ठीक है, तो हमारे पास ये सारा वैल्यूज होगा. यहाँ पर गैस का वॉल्यूम निकालना है लीटर्स में, ये भी इक्वेशन ठीक है हमारे लिए. बट अगर निकालना है गैस का काइनेटिक एनर्जी इन जूल्स, तो फिर हमारा ये वैल्यू ठीक नहीं है. फिर हम लेंगे ये वाला वैल्यू. ये आपको निकालना है गैस मॉलिक्यूल्स का स्पीड निकालना होता है। आप पढ़ेंगे स्पीड आगे गैस मॉलिक्यूल्स का, वी हैव 3 काइंड ऑफ स्पीड ऑफ गैस मॉलिक्यूल्स, तब लेते हैं हम। अगर आपको स्पीड चाहिए मीटर पर सेकंड में तो हम लेंगे ये वैल्यू आर के लिए, ठीक है। तो आपका ये बेसिक यूनिट्स हो गए सारे टर्म्स के जो हमारे इन्वॉल्व होंगे क्वेश्चंस में। अब आते हैं डिफरेंट गैस लॉज के ऊपर है, ठीक है, कि हाउ दिस इक्वेशन वाज डिराइव्ड एट, दिस इक्वेशन वाज गेटिंग और डिराइव्ड यूजिंग डिफरेंट गैस लॉज। तो हम सारे गैस लॉ पढ़ेंगे अभी यहाँ पर स्टार्ट से।